In this session, we will be setting up a Watchdog timer and running it. So we start by creating a new project, name it my WDT, and we select the EK-RA6M4 board as usual, flat project, an executable, and a bare metal minimal. Now, to use the Watchdog timer, we can simply make use of the stack available with the FSP. It's under the monitoring tab we can find the Watchdog timer. For its properties, we can leave it at its default values. The main parameters that can be configured are the clock division ratio, which can go up to a maximum value of 8192 on this board. The larger the clock division ratio, the larger is the timeout. Next is the number of cycles that can be adjusted from 1000 to over 16,000. The Watchdog timer operates from the PCLKB clock, which in our case is set to 50 MHz. Assuming the largest parameters, which is also the default for the Watchdog timer and the PCLKB of 50 MHz, the time from the last refresh to device reset will be just about 2.7 seconds. Once the stack has been added, we can generate the project contents. For our program, we would like to print some text on the terminal and then use the Watchdog timer to reset the system after a certain interval. In order to print the text in the terminal, we will make use of the Sagar RTT library. The Sagar RTT library allows our program to send data to the RTT viewer application. These files can be downloaded from the Sagar website and contains 4 files in total. The files need to be added to our project source folder. The codes for the Watchdog timer will be available under the Developer's Assistance tab. We will start by importing some header files and define some variables. Now we need to add a line to run the Watchdog timer while the debugger is connected. As we continue with our code, the first line we want to add is a headline. Once the microcontroller is restarted, it prints the line "System restarted" and waits for 3 seconds until the next execution. The next step is to open the Watchdog timer and start it. For the next step, we will initialize the Watchdog timer module. We can find the necessary codes from the Developer's Assistance. Next, we will create 2 sequences of executions. In one of them, the Watchdog timer will be reset, and in the other, it will be left alone. So the Watchdog timer would complete its counting and reset the microcontroller. The first execution is a for loop. In this execution, a print statement will be running 6 times. And during each loop, the Watchdog timer will be reset using the refresh command. Once the loop has finished, we will print a simple text to indicate that we have now exited the loop. We will now create our second sequence, which is a while loop. In the first line of the while loop, we would like to get the present Watchdog timer counter value. So we initialize a variable first, where we are going to hold the value, and then we get the command for counting those values. We can then add a simple print statement that prints the counter value every 100 milliseconds. That completes the program to run a simple Watchdog timer. We can now build the project. And then we debug as usual. To view the output in the RTT terminal, we need the address of the Sagar block. We can find this information in the .map file of the debug folder. Searching with string _Sagar will take us to the line containing the address of the Sagar block. We will open the RTT viewer application and insert this address in the RTT viewer configuration. In this simple example, we have seen how to set up a Watchdog timer for array microcontrollers. In this program, the normal operations text is printed 6 times in the console. After that, the Watchdog timer is no longer reset, so it starts to count down until it completes and restarts the system. And that ends our small demo of setting up a Watchdog timer on array microcontrollers.